Today we're going to do Unit 9, Acquisition 3, Specific Heat Calculations. So first, when we're doing these calculations, the variable that we're going to use to represent heat is going to be the letter Q. Heat is just the exchange of thermal energy. Heat always flows in one direction. It flows from the warmer object to the cooler object. So growing up, I remember I would stand in front of the refrigerator looking for something to eat, and my parents would say, "Close the door, you're letting all the cold air out of the refrigerator." If you have parents like mine, you can politely correct them and say, "I'm not letting the cold air out, I'm actually letting the warm air in." Heat always flows from the warmer object to the cooler object, not the other way around. Heat will continue to flow until both objects reach the same temperature. So think about when you have hot food and you leave it sitting there, or hot coffee or a hot drink. That heat is going to flow from your hot food or your hot drink to our room temperature air, and it's going to stop flowing when they reach the same temperature. If you leave that food or that drink there long enough, eventually it is going to be the same temperature as room temperature. So heat stops flowing when both objects reach the same temperature. If our reaction is endothermic, it means energy is absorbed by the system. If it's endothermic, heat enters the system. So this image over here is showing an endothermic reaction here in red. So if something is endothermic, heat goes in, heat gets absorbed. If heat gets absorbed, the surroundings feel colder. So heat is leaving the surroundings and entering the system. Since heat leaves the surroundings feel cooler. Like we saw in Unit 8, if a reaction is endothermic, we're going to think of energy like a reactant. Anything that gets absorbed goes into the reaction. Lastly, when we're doing specific heat calculations, if our reaction is endothermic, Q is going to be positive. We can also have an exothermic reaction. If it's exothermic, energy is being released by the system. If it is exothermic, energy exits the system. Endothermic enters, exothermic exits. So here in blue is showing something that is exothermic. This means heat energy is leaving the system. Well, if heat leaves the system and goes to the surroundings will feel warmer. Since energy is being released, we can think of energy like a product. And lastly, for our specific heat calculations, Q, which again, Q represents heat, Q is negative if it's exothermic. Mass, we know what mass is. In our equation, we're going to use the letter M to represent mass, and our units can be either grams or kilograms. The topic for this lesson is specific heat calculations. So specific heat capacity we're going to represent with the letter C. It is the amount of energy required to change the temperature of 1 gram of a substance by 1 degree Celsius. Units, joules per gram degree Celsius. That should make sense thinking about our definition. Well, how much energy, how many joules do we have to change the temperature of 1 gram, so joules per gram, by 1 degree Celsius? So how much energy does it take to raise the temperature of 1 gram by 1 degree Celsius? With specific heat, the smaller the specific heat capacity, the quicker the substance will heat up. So metals tend to have a lower specific heat. Something like water has a much higher specific heat. So if you think about a warm summer day, maybe you're at the pool, your keys are going to heat up much faster than the water will. Metals have a smaller specific heat, so they heat up much quicker. Delta T, we know that delta means change in. So delta T is the change in temperature, and the way we're going to calculate delta T is by taking the final temperature and subtracting the initial temperature. So here's the equation we're going to use. Q is equal to MC delta T. I usually call this our MCAT equation because the delta kind of looks like a capital A. So this will be MCAT Q is equal to MC delta T. These calculations should be pretty easy. All you have to do is define your variables, plug and chug. First example, how much heat is needed to warm 250 grams? So my mass is 250 grams of water from 22 degrees Celsius. So my water is initially at 22 degrees Celsius. We are going to warm it up to just about boiling, 98 degrees Celsius. And lastly, the specific heat of water is 4.184 joules per gram degree Celsius. So first thing we need to do is calculate the change in temperature. We're going to take the final temperature and subtract the initial temperature. So the temperature increases 76 degrees Celsius. Now all we have to do is plug in our variables to our MCAT equation. My mass, 250 grams. Specific heat capacity of water, 4.184 joules per gram degree Celsius. And my change in temperature was 76 degrees Celsius. Q is equal to 79,496. Rounding up to two significant figures, 79,000. Let's talk about units. Grams divided by grams cancel. Grams is in the denominator right here. Celsius divided by Celsius cancels. I'm left with joules. $79,000 joules. Q is positive. That means it is an endothermic reaction, which should make sense. If I'm heating up water, heat needs to go into the water in order for it to increase. So this is endothermic. Number 2. It takes 360 joules of energy. Heat energy or heat is just Q. So you can see all of those, they all mean the same thing. Energy, heat energy, that is all Q. My mass is 12 grams. The initial temperature, about room temperature, 24 degrees Celsius. My final temperature, 57 degrees Celsius. And we want to solve for the specific heat. So I am going to solve for C. So again, first thing I want to do is calculate the change in temperature. I'm going to take my final temperature of 57 degrees minus the initial temperature, 24 degrees Celsius. Aluminum increases in temperature by 33 degrees Celsius. Plug and chug. Alright, when we go to solve for this, I'm going to take 360 joules. I want to get C by itself. So I'm going to divide both sides by 12 grams and also 33 degrees Celsius. Keeping two significant figures, I would get 0.91. Look at your units. Joules per gram, degree Celsius. Units for specific heat. How much energy does it take to raise 1 gram of a substance by 1 degree Celsius? Joules per gram, degree Celsius. Last question. If the same amount of heat is added to equal masses of water, and aluminum, which would heat up first? So in the first problem, we saw that the specific heat of water is 4.184 joules per gram degree Celsius. In problem 2, we calculated the specific heat of aluminum, 0.91 joules per gram degree Celsius. So if I added an equal amount of energy to equal masses, which would heat up first? It is going to be the aluminum. Remember we said the smaller the specific heat value, the quicker the substance will heat up. So that should make sense. Specific heat is how much energy does it take? Well, the smaller the specific heat, the less energy we need. The less energy we need, the faster that substance can heat up.